Hello and welcome to the AAA Lead Inspections YouTube channel. At AAA Lead Inspections, we strive to provide comprehensive and top-quality information beyond our exceptional inspections. In this video, we will cover some of the basics of XRF technology, like how it works, where it can be applied, and some of the pros and cons that come along with this impressive engineering. So, without further delay, let us dive into the expansive world of XRF technology. As you may already know, lead-based paint can be deadly to you and your family if damaged, but how do you know if your paint is lead-based paint? There are two main ways to test your home's paint. First, a paint chip sample sent directly to a certified lab can tell you the lead content of the paint. However, this method has some drawbacks like cost, time, and it damages the paint within your home, which can lead to health problems. The other method is by using a device called an X-Ray Fluorescence device, also known as an XRF, that uses X-rays to measure the molecular content of a small area on the painted surface. This method is far less destructive, costly, and yields results in a matter of seconds. To start with, what is XRF technology? XRF technology can determine the elemental composition of solids, liquids, and powders, making it a versatile tool in manufacturing and construction industries. Simply put, it tells you what something is made of. This type of technology is used by many different industries like metal alloy analysis, identification and testing, mining and geology, toys and consumer goods, environmental analysis, remediation, and art and archaeometry, to name a few. And all these industries use it to identify concentrations of specific elements for various reasons. For this video, however, we will be looking at XRF technology through the lens of a lead inspector, whose job is to find lead-based paint in commercial, residential, and industrial buildings. Now that we have a better understanding of what XRF technology is, let's dive deeper into how it works, and how to use it. We have already established that XRF stands for X-ray fluorescence, and that this scanning device emits radiation to measure a substance down to the molecular level. But how is that accomplished? Inside of the scanner there is a cobalt core that emits radiation when triggered, sending X-rays into the substrate being scanned. The emitted radiation is absorbed by the electrons within the substance, they become excited, then emit specific types of energy back to the device, which are showed in concentrations, giving an indication of what kind of material the substance is made of. XRFs can also be used to give readings of a specific element, like lead for instance, that can be used to identify if that element is present within the material, and in what concentration. These readings occur in a matter of seconds, which helps industries take more samples in far less time. As a lead inspector, these rapid readings drastically cut down on house inspection times while enabling a more thorough inspection. Plus, this is a much more cost-effective way of sampling painted surfaces because there is no need to send a huge number of samples off to a lab. Not to mention, XRF analysis is a much safer alternative than paint chip analysis because of its non-destructive nature, which keeps families with lead-based paint in their homes at a lower risk of lead poisoning. Of course, we cannot discuss this wonderful technology without mentioning some of its drawbacks, one of the most major being its cost. On the lower end, XRFs can cost up $20,000, while on the higher end up to over $100,000. These prices are costly investment for newly established businesses and can take a while to pay off if without the proper clientele. On top of the cost, the core of the scanner is made of a radioactive core, which will decay over time, meaning it will have to be serviced and replaced every so often, which can cost even more money, and take away from time spent in the field gathering readings. On the topic of the radioactive core, there is an additional element of risk while operating the device as the user can be exposed to small amounts of radiation. However, the amount of radiation exposure is tiny. Here we have two charts comparing different amounts of radiation exposure accrued by different sources. Note that all units are in millisievert and that the yearly maximum allowable dosage of radiation to the whole body is 5,000 millirem, which is equivalent to 50 millisievert per year. Highlighted in green is how much radiation a lead inspector is exposed to, while highlighted in yellow are some other common sources of radiation you might be exposed to on a regular basis. As you can see, the amount of radiation a lead inspector receives from an XRF annually is less than the radiation you receive by living at sea level annually. If handling the tool properly and taking the proper precautions, there is no need for concern over radiation exposure. Briefly, in this video we discussed some of the basics of how X-ray fluorescence technology works, how these devices can impact a wide variety of industries from mining to the housing industry, and some of the benefits and dangers associated with this great invention. If you have any questions about lead inspections, mold testing, or asbestos sampling, or if you would like to learn more about these topics, visit our website linked in the description. Feel free to check out some of our other social media pages linked below as well. Thank you for watching.